So I'm coming now to slabs and see what's happening for our beams. Are loads being properly transferred to beams or not? So I'm selecting this and going to show selection only, and then 3D. Okay, so we need to see if loads are being transferred to slabs properly or not. You can see that displacement here. For sure that will cause some difference in transferring internal forces here as well. So you should have some numbers which doesn't sound very logical. Those beams are generally should have a regular moment or shear due to gravity load, but we don't have it here. Let's have a look. If I come here in frame cable tendon and then come here to compute G2, because it should be a bit predictable for you guys to figure out the correct behavior, and you can judge if the model is correct or not. So if I come here and go to moment 3.3, I can zoom in a little bit. So I can see here these beams are transferring more load. The reason is we applied a linear load on top of these beams, but not the other beams. But are the other beams taking correct load? No, you can see it's very small. There is a 1 meter tributary area for each beam, 160 slab, 2 kPa superimposed dead load, and 5 kPa live load. And I'm checking comb UG2, that means gravity factored load. So it should be something around 40 kilonewton meter if you calculate for a span of 6 meter with 1 meter bay, 1 meter tributary area. But this is just half of a kilonewton meter. So there is something wrong. What is wrong? This shell hasn't been meshed. And what would happen? The shell transferring load just to the corners and to those beams. So you see the moment somewhere like these areas, but you don't see even moment everywhere, because literally the load's going to the corner points if you don't auto mesh the shell. Let's move on and check. One thing I need to let you know, guys, these programs are progressing and they are changing the user interfaces even sometimes. So don't think that's something, if you don't know a few years ago, it's still the same. They may change it. You need to be in contact with CSI to see what are the new features and how you can use them effectively. This is pretty normal in advanced software if they are progressing and evolving. If they keep a steady state for a long term, yeah, then there is no progress. So yes, there is always could be some mistakes or some bugs because they're changing the software and updating the revisions, but you just need to do your due diligence as engineer and see what you need to do to ensure the loads are being transferred correctly. So I'm coming here to this level and I need to auto mesh this shell. So what type of element I have? 160 slab. This is shell membrane. So if this is shell membrane, if you want to auto mesh it and you want to use some joints, then the membrane doesn't show any stability because there is no stiffness. Let's try it, that's fine. So what I want to do here, I'm just coming a bit closer. I need to have some internal joints here. So I select this and then I'm coming and I'm subdividing these to say 4. So I have these joints. Now I'm selecting this one intentionally and I'm selecting this, and I'm coming and use auto mesh, and I come to this option, auto mesh using general divide tools based on point and line in meshing group. and I accept maximum size of 1.2, apply. So let's see what's happening if we run this model. So currently what we have here is membrane. So I'm running these just to save the time. I put earthquake of do not run, also p delta do not run, because I know there are some errors by doing this. So let's see what's happening here. So have a look at the periods coming. Definitely they are not the numbers that we expect. Yep, there we go. So you see these numbers are not logical. That means there is something wrong in this model. Let it finish. So very high period. That means it's very unstable and moving a lot. I haven't subdivided the mesh, but I auto mesh it. There are some dummy joints. Those dummy joints again coming into the calculation. So the issue with dummy joints is you cannot merge them, you cannot edit them, because they are not physically available in your model. So we just have to wait to finish, and then I will show you the result and see what's happening, because we are just doing some trial and errors here just to show you what is available and what you need to do. So it gives me one warning, that warning back to the ill condition or unstable condition, and I will show you where is that unstable condition. So if I come here and then I show the displacement, for example for CompUG2, you can see big movement here. So if I start animation, this is what's happening. You can see those dummy joints are moving. Okay, let's see the result of analysis. So yes, there are some issues with regards to the stiffness of the shell, but see what do we have as load. So CompUG to apply. So just for clarity, I can remove shell. So I'm coming here, not in view, apply, and I can check the numbers, but you can see something around 40 kilonewton that I told you. So 30 to 40 kilonewton. So the numbers are correct now. That means they are transferring load. So that means if we use this option, probably we don't need even add any joints. So let's do this again. I'm coming here, XY, and okay, I don't have it here. Let's come here. I'm selecting all elements, and I'm using the same option for them. So I'm coming here in auto mesh, assign area, automatic mesh, and I'm using these for all of them. I'm making this one 3 this time, doesn't matter. Let's run it again, but this time, just to save the time, I know it doesn't work, so I put it do not run, and I will run it. it's done. You can see these meshes everywhere, so I use 1.2 meter for maximum mesh size. Now I'm coming here using moment and I put it in show values. Okay, let's zoom in and see what do we have. Okay, so now this membrane is transferring load, but the issue is if we have membrane we cannot do modal analysis because of the instability and lack of stiffness. So the numbers here is something around 40. You can see, just keep it in mind, and I'll change the stiffness of the shell and see what will happen. So I'm coming here in the shell, I'll modify this one to shell thin, and then I can come here and add modifier, say 0.35, just make it a little bit with less stiffness, like a crack section. So 0.35, 0.35, 0.35. Okay, okay, and I'll just change this. So all I did, I just changed this one to shell thin, and that's all. So let's run it again and see what will happen. This part is the trickiest part of the procedure of analysis and design, guys. SAP is okay, but you can see the logic of transferring load is not okay. So you need to find a way to tweak your model to be able to complete this analysis properly before going for design. Okay, so I'm coming again here, turn on moment 3.3 and apply. Okay, let's see the numbers. The numbers suddenly changed to 7. Yeah, that means the stiffness here transferring load to the corners mainly, or to the main beams. So I'm just showing you the advantages and disadvantages of using different features in SAP. So you need to find a way. There are different ways. Some you can find a way to mesh it properly, and it may work well. That's perfectly fine. Let's go to other levels and see what's happening there. Are they showing the correct loads or not? Because if you remember, we meshed those levels, but we didn't mesh this level. So let's see what's happening here. So if I come here and select this group and then go to show selection only and 3D, so if I become close and I want to see moment 3.3, again you see the loads are not correct here. The reason is, again, this shell transferring load just to the points. Okay, so now let's have a look at upper levels. So I'm going to show all XY. So I'm going down to this level. I can activate this area, apply, okay, and again I select this, show selection only, 3D, and I'm coming closer, and now I show moment 3.3. Here, and you can see the moments here. So just bear in mind, anyway, this is a two-way slab, so matching the stiffness and displacement is important. So when a slab reaches to a certain displacement that mobilize the stiffness of a slab, it's transferring automatically to the stiffer supports. So you just need to really be mindful that how you are using those elements, and are you accurate enough in transferring load or not, Currently you can see these areas sounds okay, but in some other areas you may not see too much transferring load. So here is a wall, it's not a surprise you don't see anything. The rest you can see the numbers are different. It's back to how the loads will be transferred to those elements. We just here we didn't use any automesh, we just subdivided the shell. So you may use automesh as well to make it more accurate.